In this video, we're going to learn how to find the magnitude of a vector. The magnitude of a vector is denoted as V with double bar brackets. Suppose we want to find the magnitude of V equals I minus 6j. The formula for finding a vector's magnitude is the magnitude of V equals the square root of a squared plus b squared, where a and b are the coefficients of I and j, respectively. So the magnitude of V equals the square root of 1 squared, because the coefficient of I equals 1, plus negative 6 squared, since the coefficient of j is negative 6. So this gives us the square root of 1 squared, which is 1, plus 36, which is the square of negative 6. This equals 37 square root. Therefore, the magnitude of V, when V equals I minus 6j, is equal to the square root of 37. Suppose we had two vectors and we wanted to find the magnitude of their difference. In other words, the magnitude of V minus W. So let's say that vector V equals negative 3I plus 2j, and we'll let vector W equal 3I minus 5j. To find the magnitude of the difference of two vectors, we use the formula V minus W equals A1 minus A2 I plus B1 minus B2 j. This is the formula for the difference of two vectors. And once we find the difference, we'll have a new vector which will plug into our magnitude formula. Magnitude of V equals square root of a squared plus b squared. Since vector V minus vector W equals A1 minus A2I plus B1 minus B2j, let's go ahead and label with the information that we have. Suppose we let negative 3 equal A1 and positive 3 equal A2. Then we'll let 2 equal B1 and negative 5 equal B2. So using our formula, V minus W equals negative 3 minus 3I plus 2 minus negative 5j. Simplifying this expression, we get V minus W equals negative 6I plus 7j. Now that we have our vector, which represents the difference of vectors V and W, we take our formula, magnitude of V equals the square root of a squared, where a is negative 6, plus b squared, where b is equal to 7. This gives us the square root of 36 plus 49, which equals the square root of 85. Therefore, the magnitude of the difference of our two vectors v and w is equal to the square root of 85. Let's take a look at one more example where we're asked to find the magnitude of the difference, or rather the difference of the magnitudes of vectors v and w. So magnitude of v minus magnitude of w, where v equals negative 5i plus 6j, and w equals 4i minus 3j. We need first to consider the magnitude of each vector separately. So the magnitude of vector v is equal to the square root of negative 5 squared plus 6 squared. That's equal to the square root of 25 plus 36, which is equal to the square root of 61. Now let's consider the magnitude of w. The magnitude of w is equal to the square root of 4 squared plus negative 3 squared, which equals the square root of 16 plus 9, which equals the square root of 25. That is a perfect square, so we can simplify it to 5. The magnitude of v minus w is the square root of 61 minus 5. Because these are not like radicands, we can't combine our terms. In fact, we only have one radical, and so by convention, we could rewrite square root of 61 minus 5 to read negative 5 plus square root of 61, where our constant is in front of the radical. Therefore, the difference of vectors v, the difference of the magnitude of vector v and the magnitude of vector w is equal to negative 5 plus the square root of 61. I hope you found this video helpful, and we'll see you next time.